Before we get started talking about the paradigm shift in networking, I'd love to actually tell you guys a story. And I know it won't relate very much to what we're talking about right now, but I think you'll see how it ties back in the end. Back in 2000, how many of you guys have ACs at your house? Pretty much everybody have an air conditioner? Yeah. Ever had it break? Yeah. Don't you hate those visits from the AC repair guy? Back in 2011, my AC broke, and we did the same thing. We called an AC repairman. He came out to the house, and he basically said, your AC's dead. You know, for a whole list of reasons, there's no way we can repair it. In fact, there's so many holes in the system, all the Freon is leaked out. There's nothing left. It's like, okay, well, how much is this going to cost me? He looked at me, he said, $17,000. I didn't expect to buy a car or an AC system that day, so I looked at my wife and was like, okay, let's think about it. And of course, let's do the right thing and bring a couple other AC people out and get their bid. And we did. And they all pretty much lined up. It was like $17,000 was the minimum. One guy went all the way up to $34,000. I don't know what he was selling me, but it seemed like it was a Cadillac or a Lamborghini of AC systems. And I looked at my wife, and my wife's a really great lady. And I said, babe, can I go figure out why this costs so much? Can I understand why we're paying $17,000 for this stuff? And she's like, yeah, I'll give you about 48 hours. We have the AC on the lower side of the house, so we can move down to that bedroom, but you got about 48 hours to figure this stuff out. And the AC repairman had all left me brochures for the type of equipment they were going to put in the house. And so I was able to go online and look up what they cost. The $17,000 system they wanted to sell me, guess how much I could buy it for online? $3,000. Now, I know labor's expensive, but I don't know that labor's $14,000 expensive. And ironically, there was a distribution center, and in Virginia, where we lived at the time, you don't have to have an HVAC license if you're going to buy what's called an R14A system, which is the non-R12. And so I could go down and buy that system by myself for $3,000. So I looked at my wife and I said, can I have a couple days to try this out? And now my wife is an adventurous lady, but even she was like, I don't know, like AC is kind of important. And I said, trust me, if it doesn't work, we'll figure out how to pay for the other AC guys. She's like, all right. So I went down, I bought the AC system, and I started pulling out the old system. And one of the things that I noticed in my house when I started pulling out the old AC system was how inefficient it had been built. You know, during all my research on AC, I figured out that the number one rule around AC systems is airflow. The faster you get air into your system, the faster it cools. And the faster you get your air out of your system, the faster it cools the rest of your house. Well, the way they'd installed my AC was they brought air into the system pretty efficiently. But then as soon as it left the AC system, it took a 90-degree angle up to get past the beam. It took a 180-degree twist back down to get back to exactly where it was, except on the other side of that beam. And they took another 90-degree angle into the air handling system. So basically, my AC had died because it was working so hard to move air, because it basically had a big clog on the other side of it. So I went down to the local AC shop and said, hey, I need to figure out how to do this or to move air into my air handling or air distribution system. And they said, it's really simple. There's an aluminum shop right over there that will cost you $100. So I went and bought a new custom piece of aluminum for $100. Installed the old AC system. My wife happened to work in construction, so we had a guy that could come out and charge the system for us for around $600. So for right around $4,000, I had installed a system that was more efficient. It cooled the house 70% more efficiently than it had previously. And my bills would go down by about 30% in the summer months. Now, how does that really relate to networking? Well, what I've discovered over time is that most businesses, most companies look at networks the same way I looked at my AC before I rebuilt it. They hit a button, and the air cools, right? The house cools. We never gauge how efficiently it cools. We never gauge how much money we could save if we did it in a different way. We just hit the button. And what that has caused is a lot of bad habits in the networking industry. And we keep buying more and more devices. We keep buying the latest and latest devices, and we keep spending more and more for it. When the air conditioner repairman showed at my house and said $17,000, when the network vendor repairman comes to your business and says, here's a $100,000 piece of equipment that you need, what do? We just buy it. And as we've seen cloud evolve the way we look at networking and delivering software, we're starting to recognize that the network ecosystem that has supported us for years is at that moment in time where there's an amazing paradigm shift about to happen. Now, what is this paradigm shift in networking? Why is everything changing? Well, to be quite honest, while networks are a really critical part of everything we deliver, any software you write needs a network to deliver it to a customer. The way that we've managed, changed, developed, and built those networks have been highly inefficient. And to that, because of that, a lot of software developers have started offloading network functions off our network devices and putting them on things like servers and on what we call compute. This means that things like load balancing, we used to spend millions of dollars on load balancers, doesn't have to ever happen on a load balancer anymore. It can happen on a server that's running a load balancing function. Same thing with firewalls. And if you go down the list of network functions, routers even now today can run on servers. The only thing you really cannot have in a network replaced with a server is a switch, because most servers aren't going to come with 48 ports of 10 gig or 48 ports of 100. But this means that how we build, scale, develop, and change networks is all being disrupted. And think about it. If your company works in AWS, Azure, Google, did you ever care what piece of networking equipment they used to deliver you services? Did you ever care how they did the firewall function or how they did the load balancing function? No, you just cared that you logged into the portal, you clicked on the service you want, and that your service was spun up almost immediately. We don't get that in the networks that we own and manage and control on our own on-premise environments. And so there's all these forces disrupting networking engineering. Cloud compute is the biggest one, because cloud compute hits us in a lot of ways. The reasons we used to build out networks, minus direct connectivity to the internet or direct connectivity to our network, was because we had a service in our data centers that we needed to either distribute to ourselves, our own end customers, or to customers that actually use that service outside of our network. And AWS, Azure, Google have all allowed companies to look at it in a different way. You can do a direct connect into an AWS instance or an Azure instance, have your own private VPC, mimicking your own data center, allowing your programmers to build out a system that allows them to deliver whatever product they want very, very quickly. That means they've completely bypassed except for the connectivity into that location. Or you can have companies that spin up in public VPCs right away that never need anything more than connectivity to the internet so they can actually access their AWS, Google Cloud, or Azure instance. Think how complicated that was just 7 years ago. We used to have to build massive data centers, things like pods. We used to have to continue to update software on our firewalls, software on our routers, software on our switches. And the quality of the software that we've been getting from our companies that provide us network equipment has not been that great. If we look at just the deficiencies in security, if we look at the man-made, companies fighting against each other, deficiencies in protocols, MPLS took 12 years to roll out. There's still imparity between some vendors. One vendor wants to use one way of distributing BGP labels, or excuse me, MPLS labels, and another vendor wants to use something else. If we look at the new VPN technologies that have come out, EVPN, they all want to do it a different way. And those are sort of man-made things, companies trying to leverage disparity between vendors to try to trap you in just staying in their ecosystem. And what software developers have said, and cloud developers have said, is, why does any of that matter? I have a product I want to deploy. I want to deploy it very quickly because I can generate revenue or I can fix a problem in my business very quickly. I don't care that you don't like RFC 4107 or you want to use BGP plus label. I just want it to work. And I want it to work really, really quickly. And this has created a situation where businesses are actually bypassing the network. I think there was a Gartner study that showed that of IT spending in general, 49% of it, I think it's supposed to be around $3.5 billion this year, 49% of it is not driven by network engineering or IT groups. It's driven by businesses that go out and purchase services from a company outside their own company and deliver the product, completely subverting the ecosystem that we've looked at as the generic way of delivering services through an IT or a network engineering group. And while network engineering in the enterprise market is growing pretty slowly, cloud is growing much faster. And enterprise network engineering, or traditional vendors, have cost way too much in comparison to what those cloud providers are actually paying for their equipment. So we're getting the same product, but much smaller amounts of it, for much more than what the cloud providers are spending on their equipment. And we're seeing service providers even recognize this as well. AT&T went out and built out its own operating system, DNOS, where they used open source systems to actually control their network devices, and they're using white label switches. And they've announced that they're going to deploy something like 40,000 white label switches in the next 2 years. It's crazy. And so what that's created is that moment where the networking industry sort of doesn't have the traditional bounds it used to have anymore. We have more and more software developers. If you look at a lot of companies, they're actually looking for not network engineers anymore, but network development engineers, people that understand how to develop, use things like Linux, understand development life cycles, because they recognize that I need a guy that understands network philosophy, understands how to build networks, how they all work, but I also want him or her to be able to code the next thing that I don't have versus asking a vendor to bring it to me. And we've all heard stories of cloud and service providers moving away from traditional network vendors. I think Arista's stock dropped the other day like 9% when just a rumor was floated that Microsoft was going to move to white label switching versus sticking with Arista, which is their main switching agent. There's a couple things you can read there. One, the network industry is really fragile. If one person moving drops the stock by 9 or 10%, that means that they're heavily reliant on that one customer. And two, that they aren't really innovating in a way that people take those small hiccups and say, it doesn't matter, they're going to have a new product out next week that makes them so much better. And it's also created a situation, we've also created a situation where we're starting to lose our workforce. Google came out about 4 months ago now and stated they can't find enough people that understand infrastructure and understands development to fill the positions they have open. And they're actually hitting a critical point where they can't expand their data centers fast enough because they just don't have the personnel to do it. So we've got this aging workforce, we've got this old ecosystem on how we build, develop, and create features. And at the same time we have, and if you think about it, think about how many network software developers there are for the network. At our traditional companies, the Ciscos, Junipers, Aristas, Nokia, all those others. There's probably about 100,000 people around the world that develop software for network devices. How many software developers are there? 18, supposed to be 26 million by next year. Like, software development is moving at such an exponential pace that the resources that we can pull out of software engineering versus network engineering are vastly different. And we can retrain a software engineer much more quickly because software engineers are built around this idea that I'm supposed to know as many languages as I can. I should be good in Go, I should be good in PowerShell, I should be good in all these different things. That makes me a better software engineer. And network engineers are still sort of stuck in this rut of, I only know iOS, or I only know Junos. And that has created a situation where they're highly confined and really can only solve problems in the same way they've solved problems in the past. So why aren't we changing? I mean, there are all these forces around us, and if we look at it, what we're paying for traditional networking deployments costs way too much. There's this theory that you can actually enable your team by decoupling them from money. It's a weird statement, but think about this. If your team needs to do a project and they go to the business and they say, I need $5 million to do this, how heavy is that conversation in comparison to when they walk into the room and say, I need $50,000 to do this? If we've reduced the amount of money it takes to do the project and are still delivering a equal or even better solution at the end of it, wouldn't you really have a much more agile team if they could spend less on capital? And wouldn't you actually be able to grow your team, put more people on it that can work for you, to develop things for you, if we're not spending so much on just the hardware and software? So that decoupling of cost, related capital costs on your teams, make them move much more quickly. And if you think about the sales system, the ecosystem, it takes too long today, from both the sales cycle and development cycle. We just talked about how MPLS took over 12 years and still not completely rolled out by every network vendor. Imagine how long it would take you to come up with a new feature. Does anybody know how to get a new feature added into a network vendor's tech stack? Yeah? Got a couple out there? There's like 3 ways you do it. You either spend a buttload of money with them, and you walk up to them and say, I need this feature, and they're like, yes. Or what you have to do is be on a board like the IETF or the IEEE and mandate they do it. And mandate's a really soft mandate. They're going to do it if they want to do it, but that's pretty much how you can put it in their product roadmap. And 3, you have to create a coalition, or 3, you have to create a coalition of other companies that go to the vendors and say, we need this product. Any one of those pass, even the first one, where you're spending so much money with them they can't do anything but what you say, it's probably 2 to 3 years before you get the feature you want. Whereas software would look at that problem and say, I'm going to finish this in the next sprint. I'm going to do it in 2 to 3 weeks. I'm going to break it down into fixable parts and get the product out there as fast as I can. That completely changes the game. If we look at the sales side as well, in my history, it's taken me, on average, 2 months to get a full quote from a vendor, because they have to have their sales engineer come in and tell us we're doing everything is right, and then we have to look at the right SKUs. Am I buying that SKU correctly or that SKU correctly? I even had a situation where I had 2 VARs quoting out the same vendor, and they would come back with different prices on the same SKUs and different SKUs for the same thing. I'm like, this is way too confusing. And that leads up to my last part, confusing. Like, why do you need the product you need? Do you need the Nexus? Do you need the top-of-the-line switch, or do you just need a white label switch, or do you need something in between? How are those decisions made? We have so many things that go into our decision-making process now because we've layered so much responsibility onto the network that we're just, as a business, confused as to why anybody walks into the room and tells us we have to buy something. So we've defaulted to, those guys are smart, guess I got to buy it. And if you think about this ecosystem, what has really changed in the last 10 years? I've been doing this since 1996. It feels exactly the same way as it did back in 1996. Anybody think different? Like, have we done things better? The sales cycles are the same, just like we talked about. Deployment seems to take about the same amount of time. If I'm going to do a new big project, it's probably going to take me anywhere from 6 to 9 months, getting data center space circuits, switches, routers, all those things. Support is still the same. I still call TAC. Like, if anything breaks, I've got to call the TAC of that company, and I've got to sit on the line with them for a very long time. The only difference I can actually really see is now that everybody's moving to this continuous revenue cycle, licensing, I now get to manage licenses. So I got to manage the SKUs of the devices I'm buying, but I also know how to manage the SKUs of the licenses that manage those devices that I'm buying. So it's really confusing. And the ecosystem is really small. Think of the number of companies that actually build us networking equipment. About that many, right? We could throw a couple companies in there that do some different things, whether we're talking about Access from Calyx or Ciena, but really the companies that build us networking equipment is 5. If you think about the number of companies that provide things in software environments and companies that build their own things, the number of load balancing, open source load balancers that are out there is probably 10. And that's not even for the paid ones. If I wanted to go out and get an open source firewall, there's probably 6 or 7 of those on by themselves. There's a plethora of options, and there's even ways where people can teach me online how to build a firewall all by myself using Linux and IP tables. So the number of options that I have using software far outweigh the number of options I have in networking environments. And this has created a situation where we get into problems that we think we can solve, and at the end we fail. Everybody has heard about IBM and the Canadian government. Did you read about that? About 6 months ago, the Canadian government voided a $1 billion contract with IBM that they've been working on for, I think, over 6 years. It may have been 10, to try to build a new HR system for the Canadian government, you know, how people clock in, time, all this. IBM says they were telling the Canadian government they were doing it wrong. They didn't stop cashing the checks, but after 10 years, they still couldn't get the system to work because the people, the business owners of the Canadian government that were trying to build the product didn't understand the tech. And the tech people at IBM didn't want to do it the way they wanted to do it. And so there was no real technical driver, technical leadership. So all we were doing was just throwing away money. I've actually been in a situation like that. You know, we started to build out a cloud solution at a company that I was at. And it was very simple. It was a cloud solution. It was 40 servers at each location just so people could spin up microservices. If you need a DNS server, need an NTP server, just hit the button, it'll spin up. We started with 8 people. We figured it would take 6 months. 3 years later, we had 120 people on the team. We'd overspent by millions. The product still doesn't work to this day. I think they finally abandoned it. And the reason we got there was because we relied so much on our vendors to tell us what to do. We didn't know what we were building. We didn't take the time to go figure it out and meet with other technology leaders on what they had done in the past. And this meant that anytime we had a question, we didn't do independent research. We didn't go figure it out. We went to our vendor. And our vendor would say, 1, this stuff is really hard. You're leading the industry in trying to do it, and we'll figure it out, probably be on our roadmap in about 6 months. They continually give us that response. And, oh, here's the new way to do it. So we'd go re-architect stuff that we'd done in the past, actually changing our own software. It never really worked because we really didn't understand what we were trying to deliver the company. And the company had a mindset that you could bring generalists in, people that had just worked in random technology, and just let them do things like, oh, build a load balancer. Doesn't quite work like that. We have to change. We're at that moment where if we as network engineers and as we as the network community don't understand that what we've done in the past will not suffice for very much longer, we're going to disappear. Software development companies are going to build out things using white label switches that allow companies to use a software developer to deploy it. I mean, if you think about the protocols that work on a Tor, top of rack switch, it's like OSPF, BGP, you're pretty much done. We don't need, and they're moving all the functions to layer 3 versus trying to do all this layer 2 stuff, like nobody wants spanning tree in their network. They're starting to do things like, if you look at any switch you buy today, whether it be from Cisco, Juniper, Arista, whether it be from EdgeCore, Celestica, DNI, which are the white box label switches, they're all Linux servers underneath the covers. In fact, when you buy one from Cisco, Juniper, Arista, the bash screen you see that pushes you into a CLI is basically a cron job that runs when the thing boots up and pushes you into their CLI. But under the covers, it is a Linux server. And so what these companies are able to do now is destroy things like SNMP. Nobody really liked SNMP. It never really worked. But we never really changed it because that's what we had, and that was the best we could get. Software developer said, I can take the Linux kernel and HTTP live stream every single thing that happens on that switch in the moment that it happens on that switch, use less kernel space, use less memory space than you're doing with your SNMP job, and get more data and more granularity. Why didn't we think of that? I mean, there's a lot of history around it. I don't want to bash the network engineering industry too much. I mean, remember when we first started in the world of ASCOM Timeplex, in the world of Cisco when they first came out, there were these really special chips that you had to build to make packets move. Just like when computers started, like mainframes were big deals, right? Computers, individual PCs when they came out were big deals. But what we saw happen in the PC industry was people normalized on a certain system, x86. There's some different ones today, but primarily x86. And then when Linux came out, when Linux was introduced, there were probably 75 to 85% of all services you'd ever access on the internet were on a Windows machine. Or could actually be on an older system. Now, something like 86 to 96% of everything you access on the internet runs in a Linux machine because it's free, it's open source, and it works, it's scalable. And the reason that transition also happened was because I could move Linux to any server I wanted. I could put Linux on an HP server, a Dell server, a custom-made Quantum server. In network engineering, we don't get that. We're not getting custom-made chips anymore. Everybody's using Broadcom for their switches. Pretty much everybody's using the same chipsets for their routers. Cisco and Juniper did this thing with Easy Chip a while ago. They rotated back, but they're also looking at rotating back to standard chips that are bought on market. But our software is not portable. And it's also not scalable. It's not open source. It's still like Windows. We still have to ask them for changes. Whereas Open Network Linux, you can write any extension you want in Open Network Linux. And that can work on a router or it can work on a switch. So we're reaching that point where we have to become much more, we have to look at the world in a software development mindset, and we have to have ownership and understand the outcomes we want to achieve through our networks. And companies are starting to get it. Home Depot this year has announced plans to hire 1,000 IT professionals. Network engineering, but if you look at their webpage, it's also network development engineers, people that are actually building out systems so that they can make driving and building their sales locations cheaper, but also make them scale much more quickly. You know, I was reading a report the other day that someone said, you know, the cost of an average retail location is anywhere from $50,000 to $150,000 to deploy, meaning like put a router out there, put a switch, get the T1s, do all the things. And they said that if you used open source networking, it could be right around 30. So that's anywhere from a $20,000 to $120,000 savings. And the 30 worked across the board and actually had more scale than the other systems they were comparing. That's crazy. And those are the things that companies are looking to do. They want to be more agile, and agility requires that it costs less and has more flexibility. The company I talked about before, one of my compatriots went to Hulu. And at the company before, we talked about the mess, which is where they had expanded from 8 people to 120 people. They'd spent millions of dollars. Hulu decided to build the exact same thing that that other company had built, its own internal cloud system. In fact, they run their much more, with much more scale. It's not just for small microservices. It's actually to run the Hulu service. They took 3 guys. Those 3 guys were software engineers. The 3 software engineers looked at all the open source solutions they could. They went out and they talked to engineers. And in 8 months, they deployed exactly what the other company wanted and have been using it for the last 3 years and have been able to scale it and build it the way they want. The only thing they had to pay for, other than the hardware they were going to pay for anyway, was the personnel's time. So they've saved millions upon millions of dollars in comparison to what that other company did because they understood the problem and they understood how to solve it. And they've created a system now that they can change at their pace and not rely on a vendor to come in and change it for them. In general, I hope the message I'm trying to get across is networks are extremely important. But the network ecosystem that we have today is completely different than the network ecosystem we want to have tomorrow. And if we don't recognize that that shift is happening, we're going to miss a large window, not only for our businesses, but for ourselves personally. This can be a huge growth moment for a large amount of people in network engineering, where we can actually become more valuable to the business and make ourselves more valuable. But if we miss that and we stick into the old ecosystems that are around today, we're going to miss a huge opportunity. Thank you.
Peyton, thank you so much.
No problem.
Appreciate it. I'll steal that.
Okay.
Guys, we've got a few minutes for some questions, but I have to make a comment. I was furiously scribbling in my presentation, especially I'm going to do right now. 17 things. Yeah, got that, agree. I had one thing that I disagree. Right? I'm one of those old guys that's been around the industry for 30 some odd years, and apparently I'm a dinosaur now. So we need to work on that a little bit.
We do. Hey, I just got glasses yesterday. I had to take them off because I'm still not used to them. I thought I'd fall off the stage if I warm up here.
Well, I spent the last 2 weeks in Europe learning how to dress like a digital guy.
A digital guy?
You and I are going to have a conversation, which was clothing. Thanks so much for the deep technical insights. Obviously, you're bringing what you do every day to the stage, and we greatly appreciate that. We've got a few minutes for some questions. So, folks, anybody have a question for Peyton while we've got him up here on stage? I think we got a couple of hand mics walking around, but I'm not sure the room is so big that if you pipe up, we can't do that. Anybody? Questions for Peyton? In the middle? Yes, sir?
So one of the challenges that I see with what you're talking about
is largely cultural.
Mm-hmm.
And so a lot of the engineering teams that I have focus on, CLI based development, just like I have for your engineers, and in getting them to think a different way, they feel threatened by that. They see that as someone evaluating their career.
Yeah.
How do you overcome that?
So I'll reiterate his question because I don't think the mic was on. But the question is, he and his company have evaluated the new things that we're talking about, and when he looks at his engineering team, and tell me if I'm saying this wrong, there's been a large amount of fear about moving to these new systems and the way things work. Because it's a cultural thing. We've been doing the same thing for a very long time, and change is always difficult. Is that a correct paraphrasing of what you said? Okay. How have I overcome that? A couple ways. One, you have to recognize that you're exactly right. This is a cultural thing. And most cultures have put network engineering into this sort of box that it lives in. And you have to, one, educate the business that it's more important than they think it is. It's not just an air conditioner. It is the lifeblood of what they're delivering to their customers. There's a couple things you have to do that. One, you have to learn how to speak business and not engineering. We engineers walk into an office and we're like, dude, it can do 150 OSPF adjacencies and it's got like 80 million 10 gig ports, and the business is like, what? I don't know what that means. What I've found is that what I had to do is actually take business cases where I could talk to the business around cost savings, cost deferment. I actually had to write in a document. I did probably, in the last year, I've probably done over 1,000 pages of writing, just trying to reframe and bring to the business the idea of how things need to change and how it makes them better. And it's that continuous conversation that you have to have with the business that, one, educates them to what you're talking about, but two, educates you on how they speak. Because when you find what knobs they have around how they make decisions, then you become much more powerful. And then once you've gotten that conversation going, that's turning back around to your tech team and talking to them in tech speak about how much more efficient they can be and starting to empower them. I've seen a lot of companies where the engineers have literally been like mushrooms. They've been shoved into a closet. It's really dark. They don't ever get to go to training. So they do what they know, and they have people that they listen to that they know. Get them into ecosystems where their ideas are challenged. Take them to an open source networking event. Start to bring people in to talk to them about it. The engineers that in the last 2 years that I've seen, what we did was we brought in people that worked on Open Network Linux and just put them in a room and said, hey, design this. And they walked through it together. And then they went in the lab and they made it work. And after those things happened, the fear starts to fade. Not to say that the fear goes away, because network engineers, the excuse that I love the best is, look, if our stuff goes down, everything goes down. And that is spread across all the places in the business. If a tour goes down, and you have a backup tour, nothing goes down, right? You built for failure. You should do the same thing in the course. So as long as you're building towards that, you can overcome that excuse, but it's still going to be there. And you just have to be quite honest at some point with them and say, look, things are changing. This is the way you need to move. You make yourself more valuable, but if you don't, we have to figure out other ways to go get this stuff done. And that creates an honest conversation where people realize things are going to happen, and they can either expand their minds and get better, or they can figure out how to work on something else. Yeah.
Great. Time for one more.
Anybody?
Yeah, I don't have a mic, but I can speak up enough. So traditionally, if you have a Cisco environment, a Juniper environment, whatever, there's an ecosystem of support provided by the vendor, as well as pretty common knowledge out in the market in terms of CCNAs and so on and so forth, right? In this paradigm shift in this environment that you're saying we need to be moving towards, what do you see displacing or replacing that vendor-provided support and the community of support that enterprises can rely on?
That is a great question. Did everybody hear his question? Should I reiterate it? Basically, how do you replace the support ecosystem that's with a traditional vendor today? And that's actually on par with what the question you asked around culture. Because companies like to have that number they can dial, the whole one throat to choke mentality. If it breaks, it's their fault. Go and fix it. There are companies that are coming up with enterprise support systems around this. Cumulus Networks obviously can work on multiple sets of systems, and they can also provide you enterprise-level support. Red Hat does the enterprise-level support for Linux. You just have to look at your support ecosystem and actually ask what you need of it. I ran a report about 2 years ago that looked at all the TAC cases we had. And we had about 500 TAC cases in the last 2.5 years at this company. Only 15 of them were Sev 1s. And of those Sev 1s, do you know how many were fixed with a reboot? 80% of them. So, TAC is a great thing. Having someone to call is a great thing. It does create a lot of confidence in the business, but at the end of the day, we may be paying for something we're not using. And if you look at what empowering your engineers to do to go fix things, or even doing things like automation, as you move into Linux, you're actually able to recognize problems as they happen and adjust so the network, the business doesn't go down, and the network can self-heal much more efficiently than we can today. One of the companies I worked with about 3 years ago had actually noticed that there was a flaw in some of the BGP protocols they had deployed just from random vendors. And what they noticed was they could highlight when those things were starting to fail using Open Network Linux, because they could join the BGP session when they saw a certain set of criteria happen. They could then run an automation that would change everything from one side to the other, so keep the business running, reboot the primary side, and if they wanted, switch back later. And no network engineers are involved. And that's seeing a problem and figuring out how to fix it through automation. There are multiple ways that you can do it. Obviously, fixing the code would be a good one too. But the business has to realize that TAC, while it is important, is probably not bringing the value you expect. And we see a lot of companies actually move to I think the term is per the drink support, meaning they'll just pay every time they have an outage versus pay for everything all the time. And once they start to do that, they realize that they may not need TAC as much. It is still there. It is a very good security blanket for companies that think they need it. But if you invest in your engineers, you're actually going to pay less for your engineers. You're going to get better people and become more agile and not rely on TAC so much. But it is a journey to figure that out for most companies. And part of that is just having the conversation, writing it down, going, getting the numbers. There's a lot of people that expect their TAC's doing all these wonderful things for them when it may or may not be.
Great. Great question, great answer.
Thank you so much for the time.
Peyton, thank you so much. Appreciate it. I assume you're
Anytime.
going to hang around at the
I am.
networking break, so we'll
Yeah.
get a chance to have some folks pop up and check out your digital outfit as well. So thanks for joining us today. We appreciate it. How about another round?
Thanks.
Maynard-Koran, please.
Thank you, guys.